Hello everyone, my name is Xi Wang. I'm currently a postdoc researcher in the University of Nottingham. I'm pleased to present our work on the design and test of a 4 Revolut joint small-scale robot for the use in the education. This is the content. I will start from the background and motivation. As we all know, the STEM education, which means the science, technology, engineering, and mathematics, has become increasingly important in preparing the next generation of the engineer and inventors. And during this process, the robotic prototypes are important tools in this field because they provide the interactive hand-on experiences that can spark the students' interest and curiosity. However, many of the robotic kits currently available for the education use are either too expensive, too heavy, or lack the flexibility. There are barriers for the widespread use, especially in the classroom, where it requires the safety and adaptability. So this motivates us to design a low-cost, lightweight, and modular robot platform that can be easily integrated into the STM education. When we look at the robot structure, there are two common categories. The first is the serial robots, and second is the parallel robots. The left figure here, the serial robots typically have a large workspace but a low actuation speed and low control accuracy. Their transition mechanism are also very complex. In contrast, the right figure, the parallel robots have the smaller workspace, but they often have the high actuation speed, high accuracy, and simple kinematics. So this makes the parallel robots very suitable for the education application because it requires a high accuracy, reliability, and also easy demonstration. Here are some examples of some existing parallel robots classified by the degree of freedom. From right to left, the Agile Eye is a spherical parallel manipulator originally developed for the camera rotation. It provides 2 to 3 rotation degree of freedom, features the quick response and compact design. The middle is the Delta robot, is a most famous parallel mechanism with 3 linear degree of freedom and additional rotation degree of freedom. Features the high speed and precision actuation. They are usually applied in the industry pick and place operation, for example, the packaging. The left is the Stuart platform. It's a 6 degree of freedom parallel manipulator for with the universal application. It provides the full position and orientation control of its inner effector, makes it highly versatile. The application including the locomotion, robots, and precision machining. So based on those mechanism and design, we think about our own design. This is our design. A small sized 4 Revolut joint parallel robots. The robots consist of 2 base platform, 4 linking arms, 8 arm section, and 16 fastening bolts. The base size is around 100 mm wide, makes it suitable for the hand use, classroom use. The fully assembled robot weight is around 0.3 kg. This is much lighter than the typical commercial robot case for the actuation use. So this simple but robust design achieves the balance between the functionality and the actuation usability. The left figure is the robot prototype and actuation component. The robot is spherical, and the upper platform is supported by 4 Revolut joint chain. The design allows 2 degrees of freedom, rotation along the x and y axis. To achieve the motion, we use 2 motors to actuate them. The manufacturing used the lightweight PLA 3D printed material. For the actuation, we use the low-cost servo motor, which are sufficient for the classroom demonstration with the good accuracy. The control was implemented through an open source framework using the Arduino, enabling the easy integration into the existing teaching module. And also we have conducted the angle measurements of the central platform and also compared with the theoretical calculation. The table in the slide shows the calculated result and experimental measurement. It proves the good accuracy and repeatability of the system. The error increase with the angle increase, which is coming from the large friction in the joint at a large rotation angle. Those are all the work in this paper, and as a conclusion, we have proposed a small-scale 4-revolute joint parallel robots specifically designed for the industrial and STM education use, and compared our robot system with the existing educational robot platform. Our robot first is low cost compared with the commercial kit, and the second is it has the reduced weight, which is much easier and portable for the teacher or the educator to use in the classroom. And third, the final is we have a totally open source hardware and software, so it's easier for the developments and customization. As for the future work, first we plan to integrate wireless communication to control the system. Second is we plan to design and adjust the top of platform as a modular design. So in this way to increase the function and to make it for the multi-function use in the actuation case. And finally, so we plan to connect the system with the open source parallel robot control library, allowing the student to experiment with the complex control algorithm and the robotics programming. This is a more detailed future work about the modular design. Here we proposed two cases. The left is we can mount a laser pointer onto the top platform of the robots. In this way, it can be used to draw the shape on the ceiling or the whiteboard by controlling the parallel robots. The right is second case is we can assemble the camera onto the top platform of the robots. It can be used to visualize the robot's field of view, or later can be developed to use motor to track an object, allowing for the more interaction with the students. And finally, I would like to acknowledge our team, the Rolls-Royce UTC in manufacturing and on-wing technology. Apart from the parallel robots, we also work on the cerebral robots and also soft robots. And the soft robot is the pneumatic-driven soft robot, and the dielectric elastomer-driven soft robots. Continuing robot is the cable-driven continuing robots. The application scenario is ranged from the aero agent, aerospace, nuclear, and medical. And we have developed the robot we have developed ranged from the millimeter scale to the centimeter scale. So if you are interested, welcome to contact us. Thank you.